When deciding whether a model is reliable, it is important to consider the source of the data. Data generated by a law of physics or a geometric formula will have a mathematical model that fits the data and yields accurate predictions. With other data, such as sales records, you can approximate the data only within, or close to, the domain over which it was generated. Consider this table. Cost of whole milk in years 1998, 2000, 2002, 2004, 2006, and 2008, and average costs for 1 gallon in millions of dollars for those years. When making a prediction beyond the year 2008, say the year 2010, that's an example of extrapolation. The same could be said given this table, were we trying to predict or estimate the average cost for 1 gallon in years before 1998. Note those years are outside of the domain shown in the table. Predicting or estimating the average cost for 1 gallon of milk in the year 2005, on the other hand, would be an example of interpolation, making calculations or predictions or estimations within the domain represented by the dataset. Problem 4. Using interpolation and extrapolation. Cheese consumption. The table shows average annual consumption of cheese per person in the US for selected years from 1910 to 2001. Part A. Use cubic reg, model the data with a cubic function. Graph the function with a scatter plot of the data. That's been completed here. We can see the screenshots from a graphing calculator. And since r squared is close to 1, the fit is good. The cubic model is approximately y equals 0.0000924 x cubed minus 0.00958 x squared plus 0.311 x plus 1.802. Part B. Use the model to estimate cheese consumption for 1980, 2000, and 2012. In which estimate do you have the most confidence? How about the least confidence? Explain. Use the cubic model from Part A to estimate the cheese consumption for each year. In 1980, that estimation would be 12.6 pounds of cheese per person. In the year 2000, 29.4 pounds of cheese per person. And in the year 2012, 46.2 pounds of cheese per person. You can be confident in interpolating the estimates for 1980, that would be a y1 of 80, and 2000, a y1 of 100, because the cheese consumption fits the pattern of increase shown in the table. It's an example of interpolation. You should have the least confidence in the extrapolated 2012, that's a y1 of 112, because the cubic model increases so quickly beyond the year 2001. Your turn. Part A. Use linreg, or a linear regression model, to find a linear model for cheese consumption. Graph it with a scatter plot. Part B. A reasoning item. Use the model to estimate consumption for 1980, 2000, and 2012. In which of these estimates do you have the most confidence, and how about the least confidence? Explain.